Okay. Hope you can also hear me properly. Yeah. Okay. Thank you. So let's go. So I hope all of you already get the previous material or recorded session and also get all of practice code and also slide. Okay. I already give the access all of you in our Google Classroom. Okay. So today is our second day. Okay. So let me share my screen and show you this for today's session topic. Completing the 3 hours live training, then we talk about the problem solving class. Okay, because we have total 4 hours, 3 hours for live training, I delivered the lecture, and 1 hours for the problem solving class. In the problem solving class, you can easily share your own screen and show me your own problem, and we'll also discuss about this problem. Okay, so today's session I discuss about that mainly how to filter and displaying the satellite images, different types of satellite images were used in remote sensing, Landsat, Sentinel, MODIS, or others, any kinds of satellite imagery, how we can easily filter and displaying the satellite images. We'll also discuss about that and how to create the satellite composite. Okay, different types of satellite composite, how to create. Then how to create the different types of band combination and how to export the satellite imagery and how to import, filter, reduce, clip, and display the raster data in Google Earth Engine. Then how to create the time series of chart, mainly NDVI, we try to discuss about that. Or export any shape file or annual image composite, we'll also discuss about that. Okay. So let's go try to start one by one. So, okay, let me open the code editor. The ArcGIS Pro and also QGIS software, how to work with the image collection or satellite image, how to work, help of Google Earth Engine. Okay. So previous class we discussed about the some topic, mainly Earth Engine data type. Okay. Anyone can tell me what's the data type in Earth Engine? We find out mainly how many data types. Yes, please.
Assalamu alaikum.
Walaikum assalam, please.
So we have the data types. We have the geometry.
Yes.
We have feature collection.
Yes.
Yes. Then we have image collection.
Yes.
And the last one is the
mainly geometry, then feature collection.
Yeah,
Image
geometric
collection.
feature collection, image collection.
Yes. These 5 types of data always were used in Google Earth Engine. Okay, I also again write. Suppose first one is the geometry. Then second one is called the feature. Third one is called that feature collection. Then it's called the image, and finally image collection. Okay, so this total 5 types of data in use in Google Earth Engine for remote sensing analysis. Okay, so our today's topic is image collection and image. Okay, so this image collection, it can be any kinds of image collection, Landsat, Sentinel, MODIS, then charts or ERA5. So different types of bioclimatic variables. So different types of image collection you can easily identify from Google Earth Engine. If you check, just click on here and go to the browse data catalog. So then we find out all of image collection in Earth Engine, mainly all of data we can easily identify. Okay, so this data can be Landsat, it can be MODIS, Sentinel, or different types of data. Some data is for climate and weather data, surface temperature data, climate data, then atmospheric data, then weather data including the different types of weather data, precipitation data, temperature data. Okay, so different types of data, humidity data, wind data. So we also try to explore later this type of data. Also in atmospheric data, so including the different types of data for atmospheric data, as well as also Landsat data, Sentinel data, or Moody's data, different types of high resolution satellite imagery, okay, for a specific region. It's not globally available, but some specific region you also find out this type of high resolution satellite imagery, not for the whole world, but whole world is available. Moody's, Sentinel, or Landsat, or different types of weather data or atmospheric data. It's globally available. Okay, we can easily get this type of data. Some train data including the DEM, okay, NASA SRTM DEM, or different types of land cover data, okay, ready-made land cover data, cropland data, agricultural data. So different types of data we can easily identify. And this type of data, mainly image collection. If you click on the Landsat, then we find out the all of Landsat image collection. If you check the Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So it's the image collection. Okay, Landsat 9. What is the image collection? Series of images. I already explained about that. It's a series of images. Series of images, time series of images. If you check, Landsat 9 is available between this time. So it starts from 2021 up to present time. So it's a series of images. So that's why it's called the image collection. Same like as you can see Landsat 8. It's available between this time. So it's a series of images, time series of images. That's why it's called the image collection. It also available between this time. So this is the another image collection. So this is the another time series of image collection. This is the another time series of image collection. And finally, this is the another time series of image collection. Okay, so it's called the time series of images called the image collection. Okay, so it's for the different time or a stack of images. Okay, different time images. So it's called the image collection. Not only for that, if you check the Sentinel, you also find out the same time series of images. If you check, this is the Sentinel 1 or SAR data. This SAR data, it's available between this time, mainly series of time series of images for Sentinel 1. So that's why it's also called the Sentinel 1 image collection. This is a Sentinel-2 multi-spectrum instrument. So it's also available between this time series of images. So it's called the Sentinel-2 image collection. So it's also image collection. Okay. You can say Sentinel-3, it's also image collection. Okay. So all of those are image collection. And image collection is one kind of data type. We already learned about that. A series of images. So this image collection, how I can filter, how I can filter for removing the cloud, how I can filter for specific time period, seasonal, monthly, yearly. So this type of thing we try to explain. And if you learn only for the one data set how it will be work, then you can easily apply the same concept for others, Sentinel, Moody's, or Landsat, same, because all of our image collection, and image collection is one kind of data type. When you filter any image collection, just apply the same process all time, just apply the same process. If you check, this is the Moody's, so this is the another image collection. So here we find out the all of Moody's image collection, only time series of images. So you can see different types of product. Okay? So if you learn only for the one data set how it will be handled, so then you can easily apply the same process any other data we can easily do. Okay, just apply the same process. So now how I can filter, suppose I have a image collection. Okay, in this image collection, I have lot of images, okay, for the whole world. So now how I can filter? So first condition for filtering, it's called where you need the image. Okay, so this is the first condition, where you need the image. Second condition, it's called how you need the image. Third condition, it's called the when you need the image. Okay, so just we have filtered the image collection, where, how, and when. These three questions we simply ask, and we can easily filter any image collection in Earth Engine. Okay, it can be Landsat, it can be Sentinel, it can be Modis, or whatever. Any image collection, just apply the filtering. These three condition. First condition, where you need the image. Suppose I have a collection of Landsat. Okay, suppose I have a Landsat Landsat 8 collection I have. In this collection, suppose I find out that one suppose 1 million images. Okay, in this collection 1 million images for the whole world. For the whole world I have, but I don't need for the whole world. I need for a specific region of interest. Higher I need the image. Suppose I need the image for suppose Dhaka city image, Dhaka city region. I need the image. Then how I need the image? Suppose I need only for those images whose image will be not more than 1% cloud cover. So I filtering the cloud cover level. So I don't need all images. I need only for those images whose image will be not more than 1% cloud cover. So I filtering the image properties or image metadata. So this is the another filtering. Suppose I need the image less than, suppose less than 1% cloud cover. So this is the another filtering. Suppose I have 100 images. From this 100 images, I need only those images whose image will be not more than 1% cloud cover. Okay, and it's very important when you need the image. Okay, suppose I need the image in 2025 summer season or rainy season or any time period. Okay, so it's very important. So you can see this is the condition for filtering. When you filter any image collection, first of all, where you need the image, mainly Dhaka boundary or Dhaka city or any study area, just to simply use. Then how you need the image. So how you need the image. So in this case, we simply mention less than 1% cloud cover or less than 2% cloud cover. And when you need the image, suppose a specific time period when I need the image, we simply mention. So using this way, we simply filtering our image collection all time. So now let's take the practical example. Okay, so let me open the Landsat image. Just let me open the Landsat image collection. You can check, we find out that suppose I want to work with Landsat 9. We find out that surface reflectance, top of atmosphere reflectance, and also raw image. Okay, so this type of reflectance, basically it's a surface reflectance. It useful for making the land use land cover mapping or LST monitoring. Top of atmosphere, it mainly useful for calculating the different types of indices or others. But process is the same. Okay, it's a top of atmosphere reflectance data and it's a surface reflectance data. Okay, so both are the image collection, and when you apply, just apply the same process. So just I click the surface reflectance or top of atmosphere, just click. So you can see now it open the window. It display the all of information about the top of atmosphere reflectance dataset. So if you check the information, it show the Landsat 9, collection 2, tier 1, top of atmosphere reflectance. So you can see the dataset summary also. This is a summary page. This dataset provides the Landsat 9 collection, collection 2, tier 1. And it's calibrated top of atmosphere reflectance data. Mainly, it's calibrated top of atmosphere reflectance data, not surface. It's a top of atmosphere reflectance data. And dataset is available from, you can see, October 31, 2021. and revisit time, mainly revisit interval time of 16 days. Okay, 16 days interval time or revisit, mainly every 16 day I can get the new image for the specific study area. It's also called the temporal resolution. And if you check the tier 1, the tier 1 scenes have the highest data quality, are suitable for time series analysis. Okay, so when you identify for the time series analysis, suppose NDVI time series or LST time series, so this tier 1 is very good because the tier 1 scenes have the highest data quality and are suitable for the time series analysis. You can see that there is including the bands converting different wavelength, including the visible, near infrared, short wave infrared, thermal infrared, all of bands. And Landsat dataset is the public domain, can be used without copyright restriction. Okay, it's a publicly available dataset. So this is the dataset. Okay, we can get this type of information. So in the dataset, if you check the this, it's one kind of snippet ID. Okay, or it also called the directory of this dataset. So this type of data basically store it in Earth Engine server. Okay, in the server where it is stored. So when I go to the directory, then I can get this image collection. Landsat, this is the directory. Okay, suppose your folder directory. So same like as for in the server, have this type of directory. So just I copy this collection, just copy snippet ID or directory and paste in our code editor. So now you can see, so it show the ee.image collection, and then this is in the directory. Okay, so now this full things I want to store in a variable. So how I can create the variable? We already know about that. Before the variable name, use the var keyword. We already know. Okay, then put any name. Any name you can put. There is no problem. So I put the name, suppose L9 equal. So this is the name. Suppose it's a folder name. So in this folder, I simply store it, the full image collection. Okay, full image collection. I just store it in this folder. So now I want to check how many images are available in this folder, or how many images are stored in this folder. So for that, just use the print function and call the L9. It's my folder name, and I want to check how many images are available in this folder, or how many images stored in this folder or in this variable. So just use the size function. It's this size function computing how many images are available, or how many element mean how many images are available in this folder. So now run the code and check what happened. Just run the code. So now it's computing the total number of image collection. We can see, we find out this type of images. Okay, so this image, this is the total number of images. We find out that. Okay, 6,86,538 images. So this is the total number of image collection. Okay, for the whole world. And what is the time period for the image collection? It's available between this time period, 2021 to 2026 01 23. Okay, so this time period I find out that this is the total number of images. So this number of image collection I need to filter. So how I can filter? I already discussed about this 3-factor for filtering. Where you need the image, how you need the image, and when you need the image. So just apply this 3 condition and filter. Okay, so first of all, where you need the image? Suppose I need the image for this study area. So just suppose I need the image for this area. Just I simply draw a shape. So this is my study area. Okay, so you can see it show the geometry. So I create a geometry. I need the image for this geometry. Okay, so now this is my image collection. This is my total number of image collection. I need it for this study area. Okay, or you can choose any study area, no problem. And now what can I do? So if I just put a function, this function called filter bounds function. Okay, so this filter bounds function mainly help you to intersect with your image collection with your study area. If you want to learn more details about this function, just write the function in the docs tab and you can get the documentation. Suppose filter bounds, if you check filter bounds function, so this is the filter bounds function. It filter a collection by intersection with geometry. Okay, so this function filter a collection. So I have a collection. Okay, so this collection I want to filter by intersection with my geometry. Okay, so then we find out that only for those images which image is available for this study area. And if you check what is the argument, this argument is mainly geometry. Okay, geometry. Okay, and a geometry, it can be geometry, feature collection, or computed object. Okay, so in this time, this is my geometry. So just I copy the geometry and then I just paste here. So now what happened? So now it show this type of number for the whole world, but I don't need for the whole world. I need only of those images whose image is available in the geometry. Okay, you can say I already create the geometry. This is the variable geometry, so just I use the same variable also in here as a geometry. So I don't need for the whole world. I need only for those images whose image is available only for this study area, only for this boundary I need. So now let's check how many images we find out. So I also write the first image collection. I find out this is the image collection. It's a full image collection. So when it's available for the whole world or global. Okay, but I don't need for the global. I need only for this boundary. So further I simply use the filter bounds function and call my boundary geometry, because this geometry or this boundary is stored in this variable. So just I put the geometry in here. So now let's check how many images I find out. Just run the code again. Just run the code. I find out only 186 images. So this 186 images is available only for my boundary, only for this study area, only for this study area I find out. So now I also write it. I find out that 186, this image collection for my geometry, or your ROI or region of interest. Oh, okay. So for my study area, I find out 186 images, but I don't need all of images. I need only those images which image will be not more than 1% cloud cover. Okay, so I need only for those images which image will be not more than 1% cloud cover. So for that, I just used another function. It's called the filter metadata. So filter metadata, what is the filter metadata? Mainly this function help you to filter by image properties. If you simply search here filter metadata, so you can see image collection filter metadata. So this function mainly filtering the image metadata, and if you check, the first argument is the name, then operator and value. So what is the name? Name mainly property name to filter. And where I find out the property name of my image, if you check the image properties, so here we find out the all of property name: cloud cover, land, collection category, collection number, data source elevation, also different types of property. So I want to use cloud cover property. Just a copy. So this is the name, this is the name operator. So this is the name. So I put the name is cloud cover. Then if you check operator, if you check the what is the operator, if you check this operator, it can be equals, less than, greater than, not equal, not less than. So in this time I just choose the less than, because I need those, I need only for those images whose image will be not more than 1% cloud cover. So I put the less than, I set the value 1. So now what happened? So in my study area, I find out 186 images. But when I filter this image, only less than 1% image I need. So then let's check how many images I find out. So just I run the code, you can see what happened. So it shows that 22 images I find out. Okay. So this 22 images is, it's a less than 1% cloud cover, image, cloud cover images. Okay, so you can say if I only got the 22, but what's the duration, what is the time period? So I simply, suppose I need the image for a specific year, so I simply put here the time, suppose filter date function, when I need the image. So I have 22 images, but I need only of those images which image is available 2025 January to, suppose 2025 December 31. So 1 year, I need this 1 year image. So if I run the code, then check how many images I find out. Only 4 images. Okay. So now this 4 images I find out it's available in year of 2025. So now you can see what is the process for filtering. I again explain. So first time when I check total number of images in my collection. I find out 6,86,538 images. But I don't need for the whole world. I need only for my study area. So I simply take a study area, look like that. And if you check this study area, store it in a variable. What is the variable name? This variable name is geometry. So just I simply mention the geometry. Okay, just a minute. I think some issue. Just a minute. So this type of problem, when you face networking issue, it shows this type of problem. Okay, this code editor is not loading, or it's just not connect with the server, then we face this type of problem. It's just like as a hang. Okay, let me open the new code editor. I think it's created some problem. Okay. But same like as try the code again. Firstly, snippet ID. I take a variable name L9. Okay, and then I simply suppose I need the image for this state. Okay, just I suppose this is my study area geometry. So just in this time I simply not explain. Just I simply put here filter bounds. Where I need the image, I need the image for this geometry. Just I call and paste. Then how I need the image. So for that I simply put the filter metadata. I choose only cloud cover. You can easily get it if you check the cloud cover. I need the image in 2025 1st January from 2025 December 31. Okay, and now I check how many images I find out. So just print and call the L9. Just use the size function and it's computing how many images I find out. So we find out, you can see this type of images, 58 images for this study area. We find out that between this time period. Okay, so now this is the full image collection. We find out the large number of image collection, 86. Okay, I already discussed about that. When I filter for geometry, then it also reduce. Then when I filter for cloud cover, it also reduce. And when I filter for, if you want, I'll also show you that just a minute again by again. It will be more explained for your, just a comment this type of line and run the code. So I can see it show the first without any geometry globally for the whole world. We try to get the result now without any filtering. It shows the without any filtering. We find out this type of 6,86,538 images. But I don't need for the whole world. I need only for my boundary, only for my geometry, only for my study area. I need the image. So if I run the code now, let's check how many I find out. My study area 1635 images, but I need only for those images whose image will be not more than 1% cloud cover. So now run the code. So now it display that only of those images whose image will be not more than 1% cloud cover. We find out that 281 images. This 281 images is the less than 1% cloud cover. Okay, but I don't need for the whole time period. Okay, so what is the time period? So this time period is this time period 2021 to 2026, this time period. Okay, we find for this time period we find out that the total number of images, but I don't need, I need only year of 2025 just mentioned. So now let's check how many images I find out that. I find out that total 58 images for this study area. Okay, for this area 58 images. So I hope you also get the idea how to filter. Anyone any question? I ask me, I try to again explain. Any question for three function, filter bounds, filter metadata, and filter date, you can ask me, please. Or any confusion for any function. So first it's called, it's mainly where you need where you need the image. Then how you filter. Basically I need the image less than 1% cloud cover. And finally it's called the when. Okay, so where, how, and when. Just use the three term. Where, for the where we are use the filter bounds function. For the how, use the filter metadata function. And when, use the filter date function. and I find out that 58 images. Okay, any question about that you can ask me, or clear?
Assalamu alaikum. So, what is the global standard of the cloud cover percentage?
For the globally, it's
Mhm,
including all of cloud. Mainly, if you check the cloud property,
mhm,
available from 0 to 100%. Okay,
mhm,
so it's available 0 to 100%. We find out that for the globally, for the
mhm,
whole study area, we find out
mhm.
the 0 to 100%. But when you filter, we try to choose less than 1%. Okay,
Less than
because it's a
1%.
better. Okay, if you want, you
So,
can check. If I just use that suppose less than 10%, then check what happened. If I just put the less than 10%, so then it also increase this number.
mm,
So if I run the code, you can check. So it also increase the number 169, because in this time I'm
mm,
including the 10% cloud cover. So we
mm,
always try to keep the lower cloud cover to get the very neat and clean imagery.
mm.
But sometime we don't find this less than 1% image is not available some place, suppose
Oh,
in the coastal area or river
mm,
bank or any
mm,
place where almost cloud formation. So
mm.
then this type of place we don't find the less than 1%, it show the zero. Okay, then it show
So,
the zero. Suppose I
mhm,
try less than 1%, it show the zero. Then I simply increase the cloud level 10%, then check 20%, then check 25%, 30%. Then I increased.
okay.
Then we find out the image in here. Try to
Okay.
explain this type of thing step by step. And this place is the less than 1% is available. So that's why you find out this type of number. But if there is no image less than 1%, it show the zero.
Mm. So, it's applicable to all the images, whether from Sentinel, Landsat, Modis,
Yes,
all
yes.
the same.
This same code, you can also apply for Sentinel also. If you check the Sentinel, I'll show you what is the difference if you check. Suppose Sentinel, I just click. I'll show you the Sentinel also for another class. They also get the more better idea. But you also try the same concept, not much any hard or any different. So Sentinel to multispectral, I just choose. The surface reflects on top atmosphere. So I use suppose surface reflectance. So if you check the surface, this is the image collection. Just copy. Okay,
Mm,
just copy.
mm,
So what I just copy and paste here. Just change it. So now I
mm,
paste the directory of Sentinel to surface reflectance harmonized image. And this image study area filter metadata is important. So
mm,
for that we need to use the
mm,
image properties of Sentinel. If you check this property name is the cloud pixel percentage. Just I call,
mm.
because this is the property name of Sentinel
Okay.
to satellite imagery. But Landsat,
Mhm.
it was cloud
Cloud
cover
code.
for the Landsat. Okay, just I paste here. And others keep the
Mhm.
same. Just run the code. So now it show you the result, how many images we find out for Sentinel-2 scene.
Oh,
We find out this
mm.
is the number of images. So
Right.
same
Mm,
process. Okay, Landsat,
mm.
Sentinel, or you also
Modis,
try suppose
Modis.
same, same.
Mm,
Okay, all of are the same. If you learn only for the one, then you can also top or atmosphere also same.
okay.
Also surface reflectance, Landsat 8, 9, 7, 5, all are the same for filtering
Okay.
process.
Okay.
Always just use the same concept, filtering.
Okay. Thank you.
Continue again. So we find out this type of imagery for Landsat. Okay, for the Landsat is the cloud cover. There is no problem. If I run the code, you can check how many images we find out that total 58 images. So now I want to use suppose single date imagery. This 58 image is not captured at the same time of the year in 2025. So this image acquisition date is different date in 2025. So I have to check all of information, just print and call the L9 and run the code. Just I call this variable name and run. So now it show the all of information about this image. If you check, so it show the list 58. It means that there are total 58 images. If you check all of images, you can see all of images I have. Suppose I just click on here. Then if you check, this is the image And if you check the property of this image, just click on the properties. So I can get, this is the cloud cover of this image, this is the cloud cover land of this image, this is the collection category, collection number, this is the data acquisition date. Okay, so this image is captured 13 March 2025. Okay, this image, basically this image. Okay, this image. So same, suppose you can check the other image, same process, click on here, and we can get, you can see this is the image. So this is the image captured 2025 20 August. Okay, so suppose now I want to display this type of image. Suppose I want to display the image. Okay, I want to display the image. So how I can display? It's called the single date imagery. A single date imagery. So how I can display the single date imagery? So for that, if you check, every image have a ID. Every image have a ID. This is the ID. So this ID I need. Suppose I want to display this image. So just copy this ID. Okay. And then just I increase my font. Yeah. Then I just take a variable. I put the name, suppose image, and then use the ee.image function and paste the ID which I copy. Okay, which I copy, I simply paste in here. So now this is the image. Okay, and image have another data type. Okay, we already know about that. So you can see e.image, and I copy the ID and paste here. So now I want to add a layer. I want to add a layer. So same, just I use map.add_layer and call the image and run the code. So now it's added the layer of this image. This image is the acquisition time, you can see this time. But if you check the one problem, we find out these tiles or this scene is just cover only for this site. Okay, maximum it's not covered. Okay, it's not covered. So now what can I do for that? Suppose I need the image for this study area, but you can see which tiles I add, it just cover only for this study area. So now we try to check others. Suppose if I check others, our image which tiles is fully overlay with my study area, you can see this image is also overlay, but some only for some area, only for some area, maximum area is not covered, these tiles. So now we try to use the another tiles. Suppose I want to use this tiles and then check what happened. Same process, just I copy the ID, just I copy this ID and change my previous ID. So this is the another image, just run the code. Now let's check what happened. You can see this is the another tiles, but it also covered this part, only this part, but you can see maximum part is not covered. So this is the common problem. So when you work with big study area, then we face this type of problem. Then what the solution? We just create the image composite. We just create the image composite, then it will be okay. Okay, so now it's a big study area, and you can see this single tiles is not enough for the whole area. It just cover only for this part, but you can see maximum part is not covered. So now we create the image composite. Okay, you can also check other styles also. Suppose let's check the other tiles, what happened for that. Suppose I just use this one, just copy. But for a small study area, when you work, then we can easily identify. Okay, when you work with a small study area, so single tiles is covered, but you can see now single tiles or single image is not cover the full study area. So you can see it just cover only for this, only for a small part, only for a small part, only for a small part. So now what the solution? This solution is, it's called the composite. The image composite, and I hope you can understand about that why you need the composite. Okay, so it's very important why you need the composite. So when you work with big study area, you must need the composite, otherwise single tiles is not fully fill up your study area. Okay, suppose for this whole study area, I am image not fully cover my study area. Okay, then I choose the image composite for the big study area. Okay, and what is the image composite? Image composite is one kind of process to combine multiple images. Suppose I have total 58 images, so I want to use all of images. I want to use all of images and create a single image. So I have 58 images. This 58 images I just use, all of images I just use and create a single image. Okay, it's called the image composite.
You
It's
need to
called the
zoom your screen.
oh,
It's too far. We are not
okay.
sighting well.
Okay. Okay. So I have total 58 images. So I want to create the this. I just use all of images and create a single image. Okay, I just use all of images and create the single image. Or it also called that I just use multiple images and create the single image, and it's called the image composite. It's called the image composite. So now how I can use this type of image and create the single images? What's the method? What's the method to create the composite? So I have total 58 images. So okay, there is no problem. So I used all of images. Now how I can use? What's the process I use? So for that, simply use some method or process for image composite method. The first method is very popular. It's called the median composite. Okay, we also use mosaic composite. Is another method. We also use mean composite. We also use max composite, and also use the minimum composite or mean composite. Okay, so this 5 types of composite we are use in Google Earth Engine to convert multiple images into single images. Okay, so sometime we are use the median, sometime we are use the mosaic, sometime we are use the mean, sometime we are use the max, sometime we are use the minimum composite. So which composite when I need to use, I try to explain, then you can get the better idea how to use this type of composite. Okay, I hope you also get the idea about the image composite and what types of image composite we discuss about that. And now when I need to use, suppose when I use the median, when I use the mosaic, when I use the mean, when I use the max, when I use the minimum. So it's very important concept. And if you don't know how to use median, how to use mosaic, then you can get some problem. So I will try to explain this thing. Then I hope you also get the idea um, how to use the median, how to use the mosaic. So first of all, image composite in remote sensing, mainly it refers to the process of combining two or more satellite images, okay, from different date, different sensor or spectral bands into a single image. So our main condition, I have multiple images. In this case, I have total 58 images. I simply convert into a single images. It's called the image composite. So first of all, why you need the image composite? Why I just use the image composite? So I'll also explain that, then I'll try to discuss. So it's very important because why image composite are used. Okay, so first, image composite It mainly helpful for big sturdy study area image. Suppose whole country boundary of Bangladesh, whole country boundary of United States. Then we are just use or any big study area. For the big study area, helpful we can easily get. As well as this image composite to reduce clouds. Also remove. Okay, so it also help you to reduce the cloud, reduce the shadow, remove all noisy pixel. When I apply the composite, suppose I have total 58 images. When I just create the composite, it automatically remove the cloud, remove the shadow, remove the all noisy pixel. I can very neat and clean image here. That also improve visual interpretation in surface feature and surface feature. Suppose you want to identify something on the surface. So when you use the composite, we can get the better imagery to visualize and interpretation of land cover and surface, different types of surface features. It also help you. And it also help you to create clean for LULC. Okay. So when you make the land use land cover, this also help you with the clean input. Suppose I just create the median composite and I just use it for land use land cover, then this it will be more better. You will find out the more better result. Okay, and we can easily identify okay different types of um, features from the satellite imagery. As well as final, it's very important. Basically, capture temporal variability. It's very important. Temporal variability. Okay. Suppose I create the composite for seasonal. Okay, seasonal composite. So then it's also help you to capture the temporal variability. Suppose seasonal composite I create. It can be summer, it can be rain composite, seasonal composite, different types of season composite. As well as it also annual change when you work, then it also help you annual composite. So for this region, you are just use the image composite. And image composite, it can be different types. Okay, we already know about this type of types. If you check, we are just use this type of types: median composite, mosaic composite, mean composite, max composite. So this type of things, it's called the it's mainly called the so it's called the statistics. We simply use this type of combined image over a time of period. So median composite. So this median composite basically it's mostly wide used and it help you to remove cloud. Okay. So I also write suppose it's also remove clouds and mostly used. So it lot of time we are just use the median composite. As well as if you check the mean mainly it's the average. Okay, so it provide you the it's more data, but we also get the some noise. Okay, sensitive to noise. okay, sensitive to the noise, as well as max composite. Basically it useful for vegetation indices. Suppose you want to identify maximum vegetation or minimum and identify it useful for also use the this type of composite. Okay, so now how we can apply the composite. Okay, so I have total 58 images, and this 58 image is stored in this variable L9. Okay, so I find out the 18 total 58 images. So I want to create the median composite. So how I can do it? So for that, just take a variable. Suppose I put the variable name is median image, and I want to create the median image from 58 images. And this 58 image is stored in this variable L9. Just I copy and paste here and apply median function. Okay, so then it create the median composite. And if you just uh, add the layer, suppose map dot add layer, just I call the median image, so it create the single image. So now I can see it the another layer. So now I can see it just show you this type of imagery we find out. But if you check, this imagery have a problem. We face it's cover maximum part, but this part is not covered. This part you can see it show the blank. If I just open it, this one, so you can see this part is not showing. It's showing there is no image. It means that this place less than 1% image is not available. Okay, so for the what are the solution? I simply increase the cloud level. Suppose I put the 10%. So now let again what happened, just run the code. So now I can see now it will fill up. Okay, and you can see this is my study area. Okay, so I don't need for the outside of this boundary. So I simply use the clip function. Okay, just use the clip with my study area. Study area basically geometry. Okay, just I call the geometry and run the code. So now I can say you can get imagery. Okay. This image have also some cloud. You can see this type of pixel is the cloud, but this type of cloud we also remove. Okay, so I'll try to show you this part of the class how we can remove this type of imagery. It look like that without band combination. So now if you want to add the band combination of this image, okay, just click on here button. You can simply add, suppose this is the red, B4 is the red, the green, blue. First thing I keep suppose 98%. Apply. Natural color band combination. And so you find out this type of imagery. It's not very neat and clean. Okay, it show this type of imagery. Okay, let me try 98% again. So increase the gamma value to increase the brightness of this image. Just apply. Okay, look like that. More, I just increase. So I find out this type of imagery. Okay. So further we'll just use it this image for the different types of land use, land cover, or others. Suppose I just use the another band combination. It's called Suppose I put here the near infrared. 5 is the near infrared. Then red and blue is stressing I keep 98%. And then apply. So it's create the this type of band combination you find out. Okay. So I will explore later this type of things. Now I'm going to apply the another one, band combination. Short wave infrared 1. Wave infrared 1. They are near infrared B5 and blue I just tracing level I just put and then apply. So let's create the another band combination. So basically 3 bands make a one combination, and you can also get suppose some just simply search here, suppose Landsat, simply search. We can get a lot of resource about that. So try to follow this. Red, green, and blue. Find out this type of visualization of our satellite imagery. So this is the another. So when I apply near infrared red and green, then we can get this type of visualization. So also try to read this type of things, get the more better idea about the band combination, how it will work. And it's very useful when you work with land use land cover classification or identify different types of feature from satellite imagery. It also helps you. This is another band combination you can see. Okay, this is another band combination. So also try to use this type of band combination. Okay. So you find out this type of band combination look like that. Okay. So now suppose I need the result for another study area. So how I can do it? So same process. I just simply suppose I just call FAO. So previous class I discussed about that. It give you the shape file, mainly boundary shape file, admin level 1 and admin level 2. Suppose I just call the admin level 2 this data